Okay, we are going to continue lecture 5. Now is part 2. We already discussed until characteristic of traditional algorithm in the part 1. Now going to continue more information about the traditional algorithm. Let me give you some example, like sorting algorithm. Bubble sort is one example, starting from the time of the AI born. That was simple but insufficient for large dataset. Quick sort, highly efficient algorithm, widely used in practice. The another one, search algorithm, binary search, which is the famous 1946, and DFS we will talk later, which is start 1950, try to cover most path of the graph, and graph algorithm like Dijkstra short path and Kurzweil minimum spanning tree 1956. This is built on the minimum spanning tree for a weighted graph. This is the example of traditional, mostly follow the characteristic we already discussed. Let's recap. Traditional algorithm has some pros and cons. So the thing is consistency. Remember, because of these pros, disadvantages, the new AI again back and review the advantages of the traditional algorithm and keep it and add to the new AI and remove the limitation by adding AI. This is the point. So consistency, reliable and predictable. This is good. Exactly follow the human craft. Optimized, easy of verification and low computation, unless some several procedure, but usually low computational requirement. Totally vice versa of the AI, which has high computation. Limitation, struggle with complex and evolving problem. If your problem complex, then it is very difficult managed by traditional algorithm. And limited adaptivity and inefficient for large unstructured data. This is the characteristic of big data, which AI can easily manage it. Now let's go for AI. See AI characteristic. In this slide, we will discuss the key characteristics that distinguish AI-based algorithm from traditional algorithm. These characteristics make AI system more flexible and adaptive and powerful in the handling complex tasks. Let's see. First, it is the problem scope. AI-based algorithms have a broad general scope. They can be applied to wide range of problems, including those involving complex, unstructured tasks like image recognition, like speed processing, autonomous system. So, for example, AI algorithms excel in scenarios where the problem is not well defined or where the input data is unstructured, such as interpreting image, video, large-scale sensor. This flexibility is a major advantage over traditional algorithms, which are often limited to a specific structured task. So this is the problem scope. So let's see design process. AI algorithms are data-driven, meaning they are trained on large data set rather than being manually coded step by step like traditional algorithm. So this training-based approach allow AI model to learn from example and improve over time. Think about how an AI system like a speak recognizer or image classifier can be trained on vast amount of the data to become more accurate without requiring manual intervention for each task. Adaptability. So ability means can to be adapt, right? So AI algorithms are highly adapted. They are automatically improved as they are exposed on more data without needs for manual updates. If I give you example for this one, like Netflix or YouTube can adapt based on your viewing habits. Continuously learning, in YouTube from data or refine its suggestion, the number of review increase, the order of the video change. This adaptability allow AI system to evolve and perform better over time, right? Predictability. So this is capable of complex pattern recognition. This can identify non-linear pattern in the high-dimensional dataset, such as recognizing object in image and detecting, some fraud. This is very useful. For example, in fraud detection, AI system can analyze millions of transactions and detect a subtle irregularity between the data for a human and traditional algorithm to spot, right? Data handling. Data handling, is very important. Why? Because AI algorithms excel at handling large, unstructured data set. Whether it is image, text, or sensor data, AI system can process vast amount of the information and their performance improve as size of data set increase, right? So this is very important. That's why for autonomous driving, big data, data handling, that would be very good. If we continue more about the characteristic of AI, we can come to the interoperability. So interoperability, inter means between, interpretability. So we try to, when we say interpretation, try to interpret, explain. Interoperability means can to interpret. So AI algorithm, especially deep learning model, often operate as a black box. So this is the very important. You don't know what is the inside. This means that while they can make incredibly accurate predictions, it is difficult to explain how or why a particular decision was made. This is the point. If I give you an example, if AI system predict loan approval or medical diagnosis, it might be challenging to understand how the model arrived at those conclusions. So this lack of transparency is one of the biggest criticism of the AI, and it is a major area of research in the field of explainable XR. So usually this characteristic, the new AI, XAI, we call it explainable AI. So sometimes AI is like black box. Ability in interpretation we don't know how decide. Although is a right decision, but sometimes for sensitive issue we need to track. Handling complexity. AI-based algorithms are far better equipped to handle high-dimensional complex problems compared to traditional algorithms, for sure. They excel in the environments with the many variable and ambiguous data, right? For this is good, which we can handle, allowing to manage multi-layer relationship that would be overwhelm traditional approaches. If I give you an example, let's see, AI system can process complex data set in the fields like genomics, autonomous driving, financial modeling, areas where relation between data points are not linear and difficult to discern without advanced algorithm. Generalization, once trained on data, they can apply what they've learned to new, unseen data, which make them more, better than traditional. If I give you one example for generalization, for instance, AI model trained to recognize cats in images, for example, some cats images, can still accurately detect cats in new picture. It has never seen before. This ability to generalize across different data points is a key advantage in the real-world application, where input is constantly changing. So this generalization is not based on only the specific cat's data we already give to the system. Even not given cat data can be recognized. This through the generalization characteristic. So another is computational needs. So needs many significant resources and improvement. One of the powerful of the AI, it is this characteristic, and handle many data. Imagine like Amazon, like Netflix, system whatever learn from the behavior continuously, refining their prediction based on the new data they receive. This makes them highly adaptable to changing user preference and behavior. This is improving and improving. This is the advantages of the AI application. So if go for the example like neural network, one is example of the one example of the AI-based algorithm, decision tree, random forest, SVM, clustering algorithm, reinforcement learning. We will touch later more about them, and we will do practical things, hands-on practice through this concept. So, for instance, multi-layer, these are used for tasks like classification and regression, where the goal is to assign input to, discrete categories or predict a continuous value. And like CNN, many sort of RNN, ANN, we will discuss more. But in case of the CNN, this is highly effective in image processing and computer vision tasks. CNN capture special hierarchies in image and making idea of application like object detection, facial recognition, and medical imaging. CNN is very critical this really revolutionized a field like autonomous driving and medicine diagnosis. And this allows machine to really see and interpret image in the way that was previously impossible using the traditional algorithm. And decision trees, this is generated decision rules from data, which make them useful for both classification and regression tasks. And SVM, this is try to find decision boundary in the highly dimensional space, which make them effective for classification task. Usually SVM used for task categorization, face detection, bioinformations. This is very powerful for dataset with a clear separation between classes, but can struggle with very large dataset due to their computational complexity. So we will see more about the SVM later. Shortly we see here like K-mean, DB-scan. This is used for unsupervised learning to discover hidden pattern or cluster with data. K-mean works by partitioning data into cluster based on similarity, while this DB-scan can detect cluster for arbitrary shape, makes it more flexible. So this is more arbitrary, but this is more based on the similarity. So reinforcement learning, this is from processing aspect. This is very important. Like Q learning is the famous one, policy gradient, another one. These algorithms generally are used in an environment that requires sequential decision making, such as robotic or game AI. They allows agent to learn by interacting with their environment and receiving feedback in the form of reward or penalties. So this is the advantages of these reinforcement means learn back, some mistakes, sequential learning. This is usually in machine learning. Reinforcement learning is one of famous algorithm. So let's see some pros and cons of the AI, right? For pros and cons, I could say that for pros, we see the handle the complex high dimensional problem. So for handling large scale multi-phase detected data sets where traditional algorithm would struggle. These algorithms can manage complex high dimension data like image, text, and even video. For example, in medical imaging, AI can analyze X-ray and MRI to detect pattern. Maybe to be very difficult for human eye, improving accuracy of diagnosis, which is difficult for human. Adapt and improve over time. Over time, adapted and getting better and better. Think about virtual assistant like Siri or Alexa. This system continuously adapt to new user comment and preference, become more accurate and more they are used. Whenever you use more, that getting better. So pattern recognition. So this is the excellent to discover hidden pattern and relation in data that may not be immediately obvious to human. So this is the point. And performance on large data, AI perform, exponentially well on the large scale tasks such as image recognition, natural language processing, and predictive analysis. So this is very important. And let's see limitation. Always need a large data set. So that's why big data we discover about. Computational intensive, large amount of computation. So there is a less interpretable. This is like black box nature can make it difficult to understand, as I mentioned before. So let's make a table, which is a very interesting table, can shows this slide provide a comparison between traditional algorithm and AI-based algorithm. Let's go through each aspect to understand how these two approaches differ in their design, adaptability, performance across the various tasks. So, as we discussed before, let's start with the program scope. As you see in the program scope, traditional algorithm is specific, AI-based is general. So from the problem scope, there are designed for a specific, well-defined traditional algorithm and narrow task. They excel in environment where the problem is clearly structured, like sorting data or performing basic arithmetic operation. But in an AI-based, in contrast, is more general, can be applied wide variety of problems, even those with unstructured data and domain-specific complexity, such as image recognition and natural language processing. So AI's ability to handle diverse tasks make it far more flexible, whether it is classifying image or making a recommendation. AI-based system can adapt to different domains with a minimal manual adjustment. So when we compare two algorithms together, you see from the problem process that makes many things and useful for you to understand what is AI really. And design process. For design process, this is human crafted, this is data driven. This is human driven, this is data driven. This is manually crafted by user, everything explicit. This is based on data, is implicit. So recently, although this is good, but recently because human exactly follow human, so this is getting attention for new. They use this characteristic to combine together, make a hybrid AI. We will talk later, hybrid AI. Because there is some advantages sometimes for human crafted in terms of design process. Another one, adaptability. So this is limited for traditional algorithm. This is high, adapted for different situation. Predictability, pattern recognition. This is very basic. This is very complex and high. Recognize very complex pattern. Data handling, this is for structured data, this is unstructured data. So big data is mostly unstructured data. When we say unstructured data, such as sensor data, video, text, something. Interpretability, for interpretation, ability is transparent. Generally transparent means everything clear. But in the AI is like black box. So for handling complexity, usually in the traditional one, usually they struggle with a complex multidimensional problem and may require significant human intervention to adapt to complex scenarios. But for AI, is not like that. For AI, this is managing, handling high complexity. Generalization. So they perform well only in the predefined and previously predicted scenario. But this is for generalization. This one I am talking is a high generalization. So this is the what does it mean? AI is high generalization. That means can generalize knowledge to new unseen data, make them efficient. And computational need, low computer, this is high because too many computation. Improving manual, but this is self-improvement, like reinforcement learning, which we discussed before. Let's see some key differences in problem-solving approach. So, to do so, in problem-solving approach is explicit, this is implicit. Handling complexity suffer, traditional is okay. So this is the key difference, because we talk many characteristics. Big problem is the solving the problem difference. This is biggest difference. Handling complexity and scalability. Then if we see algorithm, how evolution happened. If we see evolution is mostly in the processing power, accuracy, and flexibility. This is when we see the history of algorithm progress. And in terms of the relation between the AI and algorithm and AI, algorithm as a building blocks of AI. Please pay attention. Do not say that algorithm, traditional algorithm, we don't need, now is a 2020 for blah blah blah. No, this is building block. AI systems are built using the various algorithms based on many concepts of previous algorithm. AI come to enhance algorithm and sometimes hybrid approach, as I mentioned. Many modern combine traditional algorithm with the AI. If I give you example, a navigation system using the both predefined route algorithm and AI for traffic prediction, right? This is the another. If I see the example for comparison between these two: sorting a list number, playing chess, and image recognition. This is very good example comparison. For example, sorting a list number, if you use traditional algorithm, looks like quick sort, a specific predefined, predetermined process. But using the AI approach for sorting is learn to sort efficiently by analyzing many examples of sorted. But here you usually doesn't learn. Playing chess. In the traditional approach, move based on predefined rule, but AI approach like DeepMind, AlphaZero, learn to play chess by playing against itself and developing its own strategy. Play and play and learn. Play and play, learn. In the image recognition algorithm, traditional use the predefined rule, but in the AI use the based on thousands of the label. So when we use the AI and big data, maybe some of you confusing. Use of algorithm, because traditional algorithm based on the traditional algorithm characteristic. So you can see that when the problem well defined has a clear and step-by-step solution. For example, as we mentioned, sorting algorithm or basic arithmetic operations benefit from traditional algorithms that follow a structured process. Efficiency. For efficiency and predictability are crucial. When we use algorithm should be this environment. Traditional algorithms provide predictable outcome, making them very ideal for the scenario when the consistency is key, such as financial transaction or system check. So input-output format are constant and do not need to adapt to changing data input. This is good. Explainability to process. So the traditional algorithm offer transparency, making it is easier to trace and justify the decision-making process, which is crucial in the sector like healthcare and finance, or for example, legal system. So in the application like encryption or file compression, where the step must be easily traceable and predictable, this is good for traditional. Let's see for AI. So if the problem complex system need to be adapted, handling unstructured data, some complex tasks, this AI is good. So AI is really good, and we need to understand both of them and try to use both of them. So now let's dive to some foundation of AI. As you can see here, I created this image like from philosophy point of view, from reasoning, from mathematics, from psychology, computer science. So from different aspects, we are going to check this one, foundation. We need to find some foundation and important part of AI. So that is from philosophy aspect, mathematical, cognition science, engineering. If you check textbook, you will see many discussion about this part, AI foundation in the textbook, psychology, computer science. So key question for foundation: can formal rule be used to draw valid conclusion? How does mind arise from the physical brain? This is the key concept which we need to consider. These fundamental questions are crucial for developing AI. Not only mimic human ability, but also provide deeper insight into how intelligence, reasoning, and learning happen. The study of AI is much more about that, answering some advanced questions for these big philosophical questions as it about building practical question. So let's little bit talk more about them. This part start with the philosophical. So as you can see from image, a philosophical idea come from a philosopher like Aristotle, nearly 400 BC, was the first to create formal system of symbolized for reasoning. His work laid on groundwork for logical reasoning. That is very related to the current AI. Aristotle tried to makes syllogisms based on the logic, such as, if I give you one example of Aristotle, like all, for example, some word, all humans are mortal. Socrates is a human, therefore Socrates is a moral. Reflect kind of deductive reasoning used in early AI system. René Descartes is another one. Introduced dualism, concept of mind and body are separated entity. This idea raised fundamental question about whether machines could possess a mind, because we said René Descartes believed that dualism means mind and body of each human, mind, soul and mind is connected together. And actually René Descartes said this is separate entity. To try to say that each one is a separate entity. Another, philosopher also, they try to argue the data-driven nature of modern AI. Like two other philosophers, especially Hobbes, he this is likened reasoning to numerical computation, which is central to how modern AI systems process data. Another foundation of AI, logical positivism and confirmation theory. When a circle developed logical positivism, a philosophy asserting knowledge should be derived from observation and empirical data. So what this trying to say, that data should be practical data, not simulate data. So what he tried to mention. And utility and relational decision making, which was started from Aristotle theory, means connecting knowledge to action, introducing idea and something else. Deontological, usually ontological, this is deontological. Ethics this is utilitarianism try to say decisions are judged based on their own outcome. Kant mentioned develop some ethics based on deontological. Try to mention the action must follow moral rule regardless of outcome. So he tried to add some morality to data. So application AI and ethical and mathematics logic in the AI, which is like Boolean logic and other stuff. So another foundation, economic and AI, how the rational agent make decision to maximize their utility. Neuroscience, how biological system, for example, brain, influence AI. Psychology, how do animals and humans think and act? How can machine? We will talk more later. Computer engineering, control theory, and linguistic means how language related to thought. And neural language processing utilize many structure to organize organize and generate human language, like Siri, Google Assistant, so forth. When we look at these sort of fundamentals, then one question comes, what is the, AI versus human intelligence. So this is because AI is often seen in the form of augmented intelligence designed to enhance human cognitive capability, not replace them. Please attention. This concept emphasizes that AI and human intelligence are complementary and necessary. While AI can support decision-making, problems of empathy, recognition, human intelligence remain in center to creativity and ethical reasoning. So this is when we talk about the type of human intelligence because we want to equal this AI. And when we see one intelligence is related linguistic, based on the language. One intelligence musical, skill in the performance. Some intelligence for logical, mathematical. Some intelligence based on the location, like architecture, artist, navigator, GIS man, designer, bodily kinestic intelligence. Some using one's body for expressions or to achieve the goal, like any dancer. Impersonal intelligence interpersonal means between the personal, like psychology, philosophers, between. Interperson intelligence, some between the person. Some intelligence, naturalistic, like between the environmentals and biologists. So another one is the linguistic, AI and types of intelligence. One is the linguistic intelligence in AI, musical or spatial, already explained. And this is information processing, learning from data. So this is the similarity between AI and human intelligence. I think to understand this slide, we need go different two slides. One similarity, this is differences. So when we go similarity means more information processing, learning from data, decision making, pattern recognition, adaptive behavior. Differences between the AI and human consciousness. This is the very important, especially for quantum physics. And Max Planck mentioned that every piece of object has a consciousness. For example, plastic spoon. If you go inside, you will find atom, proton, neutron, subatomic, and the clock subatomic point, and then you will go to the some sort of string, which is called a string theory. You will see that is moving, and it is moving based on the consciousness. That means when we talk in front of the spoon, that spoon record data. We already discussed. Later on, AI system would definitely handle this. So consciousness is very difficult for AI at the moment. Emotional intelligence, creativity, intuition. This intuition, like Steve Jobs and Einstein mentioned, most new idea come through the intuition, not through the thinking. So AI cannot handle this. General intelligence, so for this is for mostly heavy AI, and usually we call it not narrow AI, we call it AGI. We will talk later. Artificial general intelligence. Biological limitation, learning speed and data requirement. This is another problem, the AI. Contextual understanding. Human naturally understand context and subcontext in different situations. AI, this struggle for that one. And finally, as I mentioned, AI and intelligence. AI has made significant role, augment to some aspect of human intelligence, but it remained, fundamentally different in many ways with AI intelligence. So the future of intelligence likely lie on synergy between the human and artificial intelligence, which is very difficult. These days is the hot topic. Okay, we are ending to part 2 of the lecture 5.